Now we have to change to the next presentation, that is Liart Aurélie, and she will talk about wood as cultural marker, archaeological charcoal, and early societies of the Great Basin. So we will continue with charcoal. Aurélie is from Université Côte, France, and it's your turn, Aurélie, when you like.
Good morning, everyone. Thank you to the member of the WWD Foundation for inviting me to present my work today. Before I begin, here's a brief presentation. So my name is Aurélie. I'm a PhD candidate of the CEPAM laboratory in the south of France. I'm working on archaeological charcoal, and I'm interested in paleo-environment around the Pleistocene-Holocene transition, as well as human environment relationship in Nevada in the USA. So the WWD Foundation also helped to found a project which I will talk about in part today with the Association of the Desert Research Institute, the DRI, in the Nevada last October. So I would like to thank the WWD again. The archaeological site that I'm studying is Bonneville Estate Rock Shelter, or BEAR, which is located in eastern Nevada on the border with Utah in the desert research of the Bonneville Basin. This site has a very long stratigraphy with human occupation dating back to the earliest settlement of human in the region around 13,000 CalBP. The most recent occupation of the site dates from only around 250 CalBP. The level of particular interest for me is the Paleo-Indian and the early archaic levels. So the earlier level 20 and 19 correspond to the pre-Clovis period. Nevertheless, the evidence of occupation of the level of these levels are quite fleeting. Then the level 18B to 17B prime are attached to the Paleo-Indian technocomplex. The level 17B correspond to the earliest archaic period. And finally, the levels 17A to 13 correspond to the early archaic phase. Paleo-environmental data at our disposal are mainly derived from column studies. First, the basin has undergone a progressive aridification since the beginning of the Holocene. A peak of aridity called the aridity interval 1 is marked by a gradual replacement of sagebrush and pine by a community of sage coal. A brief interruption of this interval aridity around 8,200 CalBP correspond to a wetter period marked by higher proportion of juniper and sagebrush. After the end of aridity interval, a second cold oscillation takes place, called the Leviathan oscillation, where we find the same flourishing procession as during the event 8.2. Then comes the aridity interval 2, where such scales become clearly dominant. And after this period, the vegetation becomes stable with such scale and some sagebrush. From a cultural point of view, for the two main technocomplex of interest, the Paleo-Indian phase is characterized by occupation identified as short-lived. This is partly demonstrated by study of carpological remains, which identify a low taxonomic diversity, indicating a limited collection territory. As for the mineral and animal resources, they come mainly from areas far from the site, which seems to indicate a strong mobility of group over long distance. Concerning the early archaic phase, it appears that the occupation of the site became more perennial. Indeed, the carpology identifies a much greater taxonomic diversity, as well as a target harvest of the small seeds, mainly from the plants of the Amarantaceae family. As this plant developed in the salt marshes located at the bottom of the site, it seems that the early archaic group have strongly exploited this area. This is correlated with the development of basketry activity at this period, which are partly made of plant fiber from the marshes, such as the rushes. Finally, the mineral and animal resources indicate a local exploitation. So here are some examples of the questions that motivate my research. From an environmental point of view, wild anthropology allows us to precise vegetation dynamics throughout the aridification process. For more cultural point of view, is it possible to identify a selection of firewood by human groups? If so, according to what criteria? The spaces, the place of collection, the caliber, the state of the wood, the type of fire or activity envisaged? And can we link this collection method to environmental constraint or cultural choices? And all the firewood resources supply system integrate into other supply system or very independent. Thus, we change over the time and can be correlated with cultural phase. Here you have the excavation map of Bear. The archaeological samples come mainly from two sampling columns, and more occasionally, samples were taken from other squares, which sometimes correspond to Earths. So as for the methodology employed, charcoal identification is based on the principle of comparative anatomy. And as I have no reference collection at my disposal, I create one. For this purpose, around 60 modern species were carbonized and observed under reflection microscope at different magnification and different light. The microanatomical features were carefully described using the Hawaii character list, and the whole series of SEM micrograph has also been made to illustrate this atlas. Finally, some other sources allow us to complete it. The archaeological charcoal are observed and described at the same way of those of reference. All anatomical specificities of features such as fungi, radial cracks, vitrification, encountering during the observation are noted. Radial crack are phenomenal that particularly interest me. They appear when the water in the cell wall disappear as a result of seasoning, causing them to deform. And the number and the size of this crack varies according to the seasoning time. Several months of drying will result in few and large cracks, whereas a sudden seasoning, such as during a green wound burning, will result in more but small cracks. Thus, it should be possible to estimate the condition of the wood used before burning. However, this phenomenon is studied to be applied in an archaeological context by only 2 studies, and the experiments are conducted on coniferous wood. So I'm therefore conducting an experimental project on the most common species of archaeological charcoal, an angiosperm and a gnettal. So the use of the green wood can be useful in many situations, such as the lack of necromass, smoke production, or skin treatment activities, for example. However, the desert context gave rise to rather special conditions, where in temperate context, the choice of dead wood, which is easy to acquire and to ignite, is generally favored. I have observed in experiment that in desert context, dead wood is so dry that the combustion of several kilograms of wood only lasts about 15 minutes. So the use of green wood could therefore be favorable to obtain longer, more stable fire, reducing the quantity of wood needed since the environment is limited. And moreover, the notion of green wood is quite different from that used in a temperate context, as the live wood I have collected rarely exceed 10% of humidity. So let's move on to the result. Around 2,500 charcoal are identified. The Paleo-Indian levels, including the levels 19 and 20, are quite poor, both quantitatively and taxonomically. The levels as a whole are dominated by Artemisia, the sagebrush, in brown, Sarcobatus, the greasewood, in olive green, and Amarantaceae family in yellow are often present. With the exception of pine, the species identified are all shrub. For the early archaic levels, including the level 17B, few charcoal were identified. Sagebrush is still one of the dominant taxa, and Ephedra, the joint fir, becoming very important too. The pine is no longer identified, and the assemblage is now composed only of shrubby species. And finally, the last early archaic level, the level 14 to 13, they stand out from the previous one by a greater quantity of charcoal and an explosion of floristic diversity. As before, sagebrush and Ephedra still dominate the assemblages. A few arboreal species were identified, but the vegetation remains shrubby overall. And the place of Amarantaceae and greasewood is also becoming more important regarding the proportion of sagebrush. The curve of dominant taxa indicate very clearly the complementary of sagebrush and Ephedra in the fuel wood economy. This begs the question, are they the favorite taxa of the population, or they are the most abundant? Concerning the sagebrush, as I presented in the beginning, it is very well attested by palynology, but it still tends to diminish during the peak of aridity, and Ephedra has a minor role according to the palynology. But if we match the dating of the level with the phase of aridity in orange and the wetter one in light green, we can observe that the curves doesn't follow. So the use of the taxa seems to correlate more with cultural phase. We observe a quasi-absence of Ephedra in the Paleo-Indian levels and an almost exclusive use of sagebrush, except for the level 17B prime, which is separate. And whereas for the early archaic levels, the use of both taxa is common in relatively a variable proportion. The first result concerning the radial cracks of experimental material make it possible to distinguish the combustion in muffle furnace of dry wood versus green wood. Studies must be therefore continue, particularly on charcoal from open-air fire, which offer conditions closer to archaeological reality, but with fewer parameters. So the measure of radial cracks is not yet applied to archaeological charcoal. I just recalled the absence and the presence of RC, and if due to the size of the fragment observed, we are more likely to find small and numerous cracks, and therefore more likely to find green wood burning. The results vary greatly from one level to the next, but we can see that overall, radial cracks are more often observed in the charcoal of the early archaic levels. Although the studies have not yet been completed, some interpretation can already be drawn from them. The woody cover revealed by the charcoal study is a shrubland, with sagebrush and Ephedra play an important role, accompanied by Amarantaceae and greasewood. The species are resistant to arid conditions. The charcoal data complements the palynological data. The proportion of sagebrush, partly replaced by Amarantaceae over time, correspond to the pollen regional signal. Pine, which was strongly represented in palynology as the beginning of the period study, is not very rarely identified in the bare charcoal. This can be explained by the fact that the pine is a super pollinizator and that the pollen signal is regional, whereas the charcoal signal is local, as the firewood is generally collected in an immediate area of the site. However, there is one particularity. The palynology doesn't indicate a significant role of Ephedra in the vegetation, whereas the charcoal, at least from 8,300 cal BP, tends to indicate that this taxon is abundant around the site. So the question of the presence of Ephedra in the Paleo-Indian landscape arises. Two hypotheses are possible. Either this taxon only appear at the early Holocene in the bare landscape, or the population prefer to use other spaces and or not use Ephedra for fire. The increase of proportion of Amarantaceae and greasewood is consistent with carpological data that indicates the collection of Amarantaceae seed. There are species that grow in saline soil near and in the marsh, It's therefore possible to envisage the exploitation of this area for food, but also for handicraft with the production of basketry and for firewood collection. Finally, the increase of proportion of radial crack in early archaic levels could be related to a more important use of gridwood. This could be explained by the duration of the occupation of the site, which would lead to the use of all the surrounding necromass and thus the need to supplement with greenwood. But the harvesting of greenwood could also be linked to the harvesting of green plants for basketry, or to the diversification of pyrotechnological activity and the research of a longer and stable fire. The continuation of the study will perhaps shed light on this hypothesis and better identify the fuel management system of Paleo-Indian and early archaic society. Thank you for your attention.
Thank you, Aurélie. Very interesting presentation. I start now for questions. There is questions in from the other participants. I have a question because maybe I missed. Is there in respect the basketry? In the last picture you show pieces of basketry. Are they preserved by the hydration? I guess no. Dry, not totally dry preservation.
Yes, the basketry are really dry because or conserved, and because we are in a desert condition, so everything is so dry, and we have a really well preservation.
And are they made of fibers from the amaranth?
Import, yes, import, and some water grass. Sometimes bark is used too, juniper bark, for example.
Very interesting.
But I didn't do this study. It's the study of another person. It's Marion Co, who studied this in her PhD project.
I think you show very well how charcoal data complements the pollen data, no? And how it's possible to make visible species that in pollen are less visible, no? And yeah. I think you have a very good questions for your study case that I think we share for many other sites, no? That is how to identify selection or not, no? How cultural choices contribute to the taxa composition of the archaeological assemblages. So I think you have made a very good question after you have the results of your study, no? And I think the contribution of the cracks also is very interesting, no? The analysis of the cracks, no? For see this change in the firewood use, no? And what it's a very interesting question, no? If it's the result of the more permanent settlements and the need to go to the lack of dry wood, maybe. So interesting questions that maybe we need to go more deep to make an answer, no, for this. And I know it's quite difficult from charcoal sometimes, no, to arrive to the better conclusion for these questions, no. But I think your work is very interesting, and I guess you will have very good contributions to from the methodological point of view, no, for anthropology.
Thank you very much.
Thank you, Aurélie, for your presentations.